Hello, welcome back to this session on context engineering. In the last three sessions, we learned about what is context engineering, what is context tool loadout, context quarantine, and context offloading. In this session, we are going to see what is context pruning and summarizations. Imagine you're building a RAG application about some ask questions about IRS, some tax related questions, and for every questions you have some hundreds of pages of context available in the vector database. So that could be some messy tables, some graphics, some analytic information, some references. You don't need all of them. So context pruning is all about removing the content which is not relevant to this question the user is asking. Sometimes even after context pruning is done, you will have something like summarizing information. Context summarization is all about basically making that context which you have retrieved after pruning into a format which can be easily understood by the model. So in this session, we are going to understand what is context pruning, what is context summarization, and then we are going to see that with an example where we build a simple RAG application and we also have a Streamlit UI to test that application. We will see, we will apply the context pruning and context summarization. We will see the difference between what is the context retrieved before pruning and summarization and how does the context looks after pruning and summarization. We will also compare the response from the RAG, from the RAG application with context pruning and without context pruning. We use LLM as a judge using a DeepSeek model where we compare the responses from the RAG application before context pruning and summarization, after context pruning and summarizations. So that is the focus of this session. With that, let's get started. So let's first understand what is context pruning to start with. So context pruning is all about cutting down the noise before we send any document to an LLM. So first start with an example. So if we ask what qualifies as education expenses to our our RAG application, the retriever goes into the knowledge base, which is our vector database, and pulls back a large set of chunks. Some of these chunks are helpful, like actual list of qualified expenses or eligibility rules, but mixed in are a lot of things that doesn't directly answer the questions. So it could be a disclaimer, historical notes, or even some unrelated sections on medical expenses and transportations. So if we just send all that to the LLM, it has to process everything, which costs more tokens and increase the risk that model get distracted. So pruning introduces a step where we filter out irrelevant material. The idea is to remove what clearly doesn't support the answer. So the LLM work with the smaller, more focused context. So the benefit is obvious. You get a cheaper and faster responses, and more importantly, accurate response and a cleaner input for the model. But there is also a risk. If the pruning is too aggressive, it might remove an important details like an exception clause or a condition. So you need to balance it out, like what to prune, what to not to prune. You need to be really balanced here. So pruning is useful but need to be applied carefully. It's about striking that balance between reducing the noise and not cutting all the irrelevant details, so that the accuracy of your response should not suffer because you removed some important details as part of the pruning. That's what important is. The balance is what very important. So now let's understand what is context summarizations. So unlike pruning, which simply cuts out irrelevant pieces, summarization takes all the information retrieved and rewrites it into shorter, more focused versions. But crucially, it keeps all important details. For example, if you retrieve a huge chunk of document related to some IRS documents, we might see a long explanation, multiple examples, disclaimers, and repetitive rules. That's a lot of for LLM to process. And much of it is just a verbose text, and that doesn't need a new meaning. So with summarization, we pass those along chunks through a process that condenses them into clean, structured summary. The summary keeps the key facts, the eligibility requirements, and any exception that matter, but it eliminates the filler and repetitions. The result is shorter, easier to read context that LLM can work with more efficiently. The model sees the same essential information, but the format that is cheaper, faster, and then maybe less confusing for the model. So, in summary, while pruning risks the cutting too much, summarization aims to strike the balance. It makes the content very focused but without losing the accuracy. Now that we looked into the pruning and summarization, honestly, this pruning summarization is kind of very intuitive. It's not like really a complex thing to visualize, right? Basically, somebody is giving you a large chunk of documents, you just remove which is not relevant. And basically, if you're having a lot of messy meeting notes, you basically condense them, summarize them into a format which you can distribute to all your team members so that they can easily understand. So, but how do we do this in LLM? There are three main approaches. First thing is you can use general purpose LLM. This is the simplest option. You send retrieved context to a large model like GPT or Claude and ask it to extract or summarize. The advantage is flexibility. It works across any domain without special training. But the trade-off is cost. Since if you are using OpenAI or Claude, it is going to be expensive to have API calls. That means you negate all the cost benefit of the pruning by using this model. So this is not really ideal in a lot of situations. Second approach is you take a small model which you can deploy on your own, maybe as Expose API or maybe use the API based. You fine tune the smaller model. So here you take a compact model and train it on your domain documents, say a medical regulations or tax guidelines or any other your internal documents. Over time, the model learn how to summarize and prune effectively for that domain. The benefit is much cheaper inference at scale, but the trade-off is upfront investment in label data or training. And there are some other models like Provence. They aren't generally LLM, but rather a model designed specifically for relevance ranking and evidence extractions. They're very efficient at filtering out noise and highlighting only useful passages. The trade-off is that they are less flexible. They work great in the trained use case, but they will not generalize outside office. So overall is that you can take a large models which are flexible but high cost, or you can strike a balance where you can take a smaller models, fine tune that model on your specific domain or maybe the specific application, RAG application, so that it knows how to prune or summarize a document for that domain, right? That is more kind of a striking the balance. Now, this is important point we need to also understand. The pruning and summarization is not cheaper by default. So what you see is that one way you can see is that you can use some small large model. If you use something like GPT-4 to both prune and then answer the question, you are actually paying twice for the more expensive model. It's like doing a RAG on RAG, right? In this case, you might even increase your cost instead of lowering them. So, but there is another way, which is you take a small inexpensive model, like you can take something like a Llama 8 billion parameter model, which you can host on your own, or maybe you take another still smaller model, but specifically fine tune that model only for pruning and summarizations, right? Then that model can condense your a large 20,000 tokens into 5,000 tokens. So this is what I think. This way the lightweight model does all the heavy lifting on compression, and expensive model like used for to answer the questions or do any reasoning of the agent. So the thumb rule is prune with small models, answer with large models. That's only way pruning and summarization actually delivers you more accurate responses at the lower cost. Now I'll walk you through the code of this context pruning. So the approach we are using is I'm having three models. I'm having one model, a smaller Llama 8 billion parameter model I'm using through the Grok API call. I'm using that model to summarize or maybe pruning and summarization. And I'm using GPT model, GPT-4 model to actually answer the questions. And I'm using a DeepSeek model to have LLM as a judge. So what we do is we are building a simple RAG application. This RAG application, basically we are doing it for answering the questions related to tax. So I'm taking around 4 or 5 IRS big PDF files, chunking them, and then loading this document into Pinecone vector database. And when user asks the question, I retrieve the relevant chunks and then pass on the relevant chunks to the Llama 8 billion parameter model with a prompt, that model is going to actually prune and summarize the context retrieved from the vector database, and I'm going to pass this context to the LLM to answer the question. Once I get the response, I do without pruning and with pruning, and I pass both the responses to DeepSeek and ask it to evaluate which is a better response. So that's what we are going to do in this demo. So as usual, we load our environment files, which is having all our API keys, like your DeepSeek API key, Open API key, Grok API key, everything is there. So we are enabling the Langsmith to track. So first thing is that I need a DeepSeek LLM. So why I need this DeepSeek LLM is to do the comparison of the RAG response without pruning and summarization and with pruning and summarization. So for LLMS judge evaluation, I am using this DeepSeek model. And similarly, so now we are having RAG, so we are having Open API key. On Pinecone is our vector database, so we are going to chunk and load all the documents there. And then we are also having Grok API key for the Llama 8 billion parameter model, right? So if you have some GPUs, you can also host this model on your own. So we are using this OpenAI embeddings, the small text embedding model, to have the embeddings to generate embeddings for this one. And so this is our pruning LLM. So I'm using Llama 370 billion parameter versatile model. So temperature 0.1, and I'm using from the Grok. Okay, this is a Grok API key. So now I'm having answering LLM. I'm using GPT-4o model for my answering my LLM. So this is something like we do the text splitter, chunks of 1000, overlap 100. We are not going to spend too much time on chunking. Our whole idea is just to understand how to do the pruning and summarization. So it is a simple recursive text splitter. And then I'm Pinecone. I'm this this is my index name. So what I'm doing is we'll go through the code. We'll also see that. So first, this is our pruning prompt. So what is the pruning prompt? You are saying you are expert summarizing technical. So we are giving the rules. So you need to preserve all the key facts, numbers, example relevant to the prune, critical condition, relationship between the concept. Then condense something you should remove repetition, disclaimers and filler text, replace long phrases, concise and precise wording, and style and the guiding principle. Okay, we are also giving something should be 50-70% shorter than the original text while retaining 100% of the essential information needed for the accuracy. So this is our prompt. We can play with this prompt. Maybe you can see the percentages. You can do the way you want. But this is a prompt I'll be using to prune and summarize. So first we have to load the documents into the vector database. So I'm having vector store. We're creating the index. Okay, and then we are load and indexing the documents. So we'll go to that method. So here I'm having these 4 PDF files. One PDF file about the federal income tax, second PDF file about tax benefit for education, third about travel, gift and car expenses, medical and dental expenses. So I'm loading these 4 PDF files, each around some hundreds of pages of PDF files, into my vector database. So I'm using PyPDF loader. I'm loading this document, and then I'm doing splitting the documents, and then from the documents I'm creating a chunks and then loading it. Now I'm writing a simple method, retrieve context, will return the top 5 chunks. Okay, basically this goes and then does a similarity search on the vector store for that query and then retrieves the top 5 documents. Okay, and then this is some literal analysis for I just added to, if at all you want debug, like how many chunks are coming, what is the total length and all the stuff. So this is not really relevant for this. This is only if at all you want to print some diagnostic results of what is your total chunk return and everything. Then this is also to identify the concept, when you're loading, whether it is a table of contents or metadata or some introduction, procedural information. That is just some kind of a method. Now this is my LLM judge comparison. This is where I'm passing both the answers before and after with pruning and summarization, without pruning and summarization. I'm passing both here. I'm asking this to check on 4 parameters: relevance, accuracy, completeness and clarity. And in the end I'm asking it to give a rating for each of this. and give a final ranking, which is the first place, just second place, and also summary. So now once you do the answers, you first take the user question, answer that question as a plain rank without any pruning and summarization, and then same question you answer after you have done the pruning and summarizations. You pass both the responses to DeepSeek with this prompt, and you are asking the DeepSeek to evaluate which is a better answer. Okay, and then it invokes, it prints it. Now this is about parsing the score, the judge scores relevant, so that you can easily print in the UI. Okay, and then you have exact score from LLM lines, and this is a comparison method. So you take the user query, so you first retrieve the context. Okay, this is my original context. Then I am running this original context using a plain rag. So based on the following context, please answer the questions. I am passing original context and the query, and then I am getting a plain answer. Now next is that I am using llama 70 billion parameter pruning model to prune that. So you got the original context you are passing here, and then you are running this, you are passing the user query and the context and asking the model to remove irrelevant information and also summarize the context. Now I am taking this pruned prompt context, and then I am again running that through the LLM. So now I am having two results, one without pruning, with pruning. Now this is my answers are my plain answer, a pruned answer. I am having original context, plain context. I am passing both of them to the LLM as a judge comparison, right? Both I am passing answers and passing the context, and then is return this method. Now this is the RAG application. Either I can run through CLI, but I also build a UI using Streamlit so that it will be kind of easier. This is just, I don't know, this is kind of big, Streamlit UI. You just need to ask Claude to generate the Streamlit UI code. Depending upon your requirements, you can define how the UI has to be, like what is the left navigation bar should have, what is the right navigation bar, how you want to display the original context, previous context, where the bottom has to come. You describe all the specification, and then I generated using Claude all the Streamlit, right? So this is Streamlit code which will display. Now what we'll do is we are going to walk you through, we'll see the actual demo. We'll take some questions, ask the questions, and then we'll see that in the. So now I'm running this Streamlit application. So it has opened this page here. So I'm having a simple UI here where I'm having raw context from demo. You have some default questions. Now we'll pick up one of the questions and then ask the question and then see how the response is going to be. So now let me pick up something like, what are educational tax benefits available, right? And then let's see the get answers. Now we'll see when we go here that now it is query what education, retrieving the plain with OpenAI, running because it already got the context from vector database. It is running the plain RAG with OpenAI. Once it is done, it will again do the pruning, and then it will again do the LLM as judge comparison, and then we'll see the results. It may take few seconds. Now it's running that pruning, now generating answers with OpenAI. It is a plain RAG, and now running LLM as judge. This was typically takes few more seconds because you need to compare both the response. Once it is done, you should be seeing a response over here. Yeah, now we can see that response. So this is the original retrieved context for this questions. Now you can see that this is all the context it got. It has got around 4,916 characters. Okay. Now you can see that the pruned and summarized context, it has basically condensed everything into a clean summary. It has reduced almost 62 point got reduced. Now we'll see the answers. Answers wise, you can see the plain RAG and LLM pruning. Okay, these are answers. This is LLM judges evaluation. Now you can see the plain RAG, it has given relevance of 9 out of 10, accuracy 9 out of 10, the overall score 34 out of 40. It is slightly better. LLM summarized RAG is slightly better, but what is important thing is that you have used a open source, a small model, right? You are not incurring big cost in doing pruning here. It is very small model you can host on your own, or maybe sometimes you can fine tune your own small model and use it. and with that you are able to reduce your context by this much. That means your context, if you see here, from 4019 character has come down to 62%. That means less number of tokens you have. When you have less number of tokens, obviously your cost is going to be less. Assume that you are asking some, like, some 100 to 1000 questions you're running per day, and then the less number of context means you have very low cost, right? So this is about the context when summer, and also see that more you have very focused context available for the LLM, you can see that even the answers are relatively better here with the summarized context. It has given all the eligible conditions, some important notes. It has cleanly break down your tax credits, your reductions, your tax-free benefits and everything. But which is not the case with the year, because here you're throwing everything to the. Of course, you can still do the re-ranking and all the type of techniques where you pick essential chunks, but you still, you are passing. You could still, the each chunk could be like very large chunks, maybe, right? Still you're passing lot of context, but instead of that, if you can see here, assume that even if you have done the re-ranking and got only top 3 or 4 chunks, you still have got a lot of data. But whereas here you can see that it is properly summarizing everything into different sections, and it is making the job of your LLM to answer it, really easily. And that's what you could see here in the LLM comparison. Relevant, there is a difference in the relevance, accuracy more or less same. The completeness, this is slightly scoring above, and there is a slight difference in the response, the ranking. But the more important thing is that your context is less. So if you are using it like multiple times in a day, in fact, if you are using a sort of AI agent which is continuously running, obviously instead of bloating up your context, lot of irrelevant information, every time you are calling agent, you are actually condensing that, you are actually summarizing the context, which is going to really save the amount of money you spend on each API call. That's about the context pruning and summarization.